Welcome to Disruption Dialogues Podcast Season 2. Listen to the influential leaders and trailblazers from around the world as they share invaluable insights to navigating the fifth industrial revolution.
Hello, everyone, and welcome to yet another episode of Disruption Dialogues Season 2. Today, I, Vinod Chikkareddy, am in conversation with Prasad Joshi, the Senior Vice President of Emerging Technology Solutions at Infosys. Prasad is a very tenured leader in the technology space and has seen several shifts in the computing space over the years. He leads Infosys Center for Emerging Technology Solutions, which is a key unit responsible for building expertise in emerging technologies, contextualizing them, and creating business solutions for Infosys customers. Prasad has been instrumental in building the Living Labs program at Infosys, and through it has set up co-creation labs with a lot of the key clients that they work with. Today, while Prasad, of course, brings in deep knowledge of a lot of the emerging technologies, our focus will be on the hottest one of them all, generative AI. Maybe you hadn't heard about it last year, but I'm sure every one of you who's on this call listening in has heard about generative AI, ChatGPT, the whole works. Welcome, Prasad. Welcome to this conversation.
Thank you for having me, Vinod. Pleasure to be here.
Thanks again. I always keep wondering, right? I'm a computer science person as well, been in the space and learning for almost 3 decades now. And when I started first looking at computers back in the 90s, AI was the hottest thing even back then. When we initially spoke, you mentioned how Marvin Minsky came up with the first neural network in 1951. And the ELIZA chatbot was a reality back in 1966. And now we've got the latest chatbot called ChatGPT, I guess. So what do you think is happening here? What is really new with generative AI, the ChatGPT space? And hasn't AI always been around? And why does AI keep coming up as this new thing every decade?
I think you make some very valid points, and thanks for sharing the history. Just tongue-in-cheek for both of us shows how long we have been in the industry and the kind of ups and downs that we have observed, especially with me focused solely on technologies and my literally entire career looking at these options. When I was a student, I used to study the AI algorithms of then times. So as a popular example would have it, what we call as Roomba today used to be a dot that was doing space planning, obstacle avoidance kind of algorithms. And today you have very sophisticated bots in the house that can roam around and clean things, mop floors, avoid obstacles, remember maps, take orders, interact with other devices, and so on. Now, why does this happen? I think it happens because there is a confluence of technologies. When some of these capabilities were being built, either they were isolated events and a deep research was happening, or they were happening in isolation. And today that has changed. I think if you ask me what is the most significant change that has occurred is neural networks have evolved over a period of time. Even before ChatGPT or OpenAI announced its public availability, and then what happened since November 2022, generative AI has been around. There were previous versions of GPT, the core technology behind this capability, has been around. We have been using it. We have been using it for translations of programming languages, for example, as a way. But going to what you and me started with, if you look at the role of GPUs, a role of how computing can be performed on a massive scale at a relatively lower cost. Even today, I think if you look at how some of the underlying technology with large language models and so on, they're very expensive technologies, even with today's standards. They're massive, massive investments that would be required. The power consumption is huge when you look at in those terms. But at the same time, they were not feasible at some point in time, and they were experimental, they were being modeled, and they were worked on a very small scale. So the popularity or the groundbreaking nature of what we are seeing was not achievable at that time. They proved the theories, they proved the models. A large part of that, the time period that you referred to, early stages of our careers, AI was more rule-based. It was attempting to mimic what human thinking and human logic was. Logic programming, symbolic reasoning were the tenets that we used to learn in those years and implement systems. I remember creating my first expert system on similar lines. Over time, I think the evolution has brought in technology terms where AI, if you may call it, it's sort of unexplainable AI is how originally neural networks started to come into the picture, and we'll hopefully touch upon some of those areas, but that explainability becomes a critical factor. Now, that was first class if you looked at what Prolog used to do in its early years. Explainability was built into the programming language. You could simply trace the stack and you would know what decisions were made and why they were made. It was emphasized on symbolic reasoning. So what was used for computing was understandable by humans, eyes, ears kind of senses. And there was a degree of comfort. Today, some of that now needs to evolve. And I think that's the change that we are seeing. So if I was to fulcrum it, significantly higher computing power, significantly improved theories and models that have come up, significantly improved ingestion capabilities that happens well supported by things like cloud computing, massive data availability, policy changes to an extent that have occurred in the process. And that's where you see the shift in AI from early decision-making systems to today, is humanity under threat kind of gallop that has happened in the process.
Absolutely. I do agree that the availability of, for lack of a better word, just cheap hardware where you can train data models. And at Markets and Markets, we've been working with a lot of clients to help them figure out what Gen AI means for them, what the new evolving use cases are, and what's coming to the fore. And it's a lot similar to how it worked with the semiconductor industry, right? So every 18 months, we would expect a doubling of the computing power available through a semiconductor chip. And we are hearing something similar on the AI front. People are talking about, whether you talk about OpenAI, Bard, or even Llama 2, which Facebook just introduced, Meta just introduced. They're all talking about bringing neural computing power, the generative power to the masses. And it's all about democratization, creating these, I would say, data sets, which are valuable in a very specific context, and bringing down the training time for months and years down to a few days, maybe a few weeks. And that's where I think a new set of use cases will also emerge. And it will truly become a democratic offering. So great to hear the history on this. And I would like to then look at the next step, which is what the technology backbone looks like for all of this engagement that is going on. And we already started talking about it. And increasingly, we are hearing customers talking about how they will compartmentalize data centers to the point where power generation itself can move into the data center. They don't need external companies providing them with power. The cooling will be done again, largely in a contained environment. If AI were to be provided in such an environment which is self-contained, what would be those new technology trends that will emerge? Who are the infrastructure players, the technology players who stand to benefit from this shift to a new paradigm of computing, where the laptops or the end devices take charge of the AI versus the big box servers that are there today? Your thoughts on how the computing form factors would change?
I think we will see some shifts, as in if you looked at how basic computing itself evolved, and let's take a few mile markers, mainframe computing, then the client-server computing, the web-centric technologies or distributed computing, as we knew, the push towards cloud and what it creates. Cloud computing really gives you a perception that there is a infinite pool of computing power, memory, storage available. and that it somehow can be used in that manner, and in the process also makes it cheaply available pay-per-use kind of models that have come up. A lot of this is very, very conducive to experimentation on the lines of AI. But we should, I think, also visit what has changed in the AI itself, where you start looking at, in very simplistic terms, graphs being evaluated in a certain manner, and those graphs then being layered in a way where the networks start to create a decisioning approach where multi-layered networks use the one before to produce the outcomes. Now, is this fundamentally a new concept? No. Even if you look at the good old logic gates, as we used to call them, and learn the logic programming around at that fundamental level, they were doing something very, very similar in that process, and it has evolved. And then we started separating at a computer architecture level what was one single chip into significant memory processors, significant CPUs, significant network processors, and specialized computers that came into my data center to work these things. Over time, they all got virtualized, which is what we started calling as cloud computing, and they are available as required in that process. GPGPUs joined that journey. So today I can rent GPGPUs, which in some sense was a very specific, purpose-built, originated and rooted into graphics computing, where you were looking at screen computing, and the dots and bits that are on screen can be done in a certain way. Very useful in neural network concepts. Now, shifting to the software side, I think the network's propagation algorithms and capabilities have evolved to a inflection point called transformer models. And these transformer models are very, very significant, that led us to creation of the large language models. I'm avoiding theory behind this, simply leaving some of the keywords so that some of those who are interested in going through can actually pick up the details, or we could do detailed deep dives as the case may be. But this part created what is essentially very popular as ChatGPT. That's essentially the fundamental technology underlying that. What does that do? It creates a semblance of a general AI, and that ask any question and there will be answers. And you saw very clear disclaimers that said, if you ask me something before a particular date, I'm good at it. If you ask me something after that date, I'm not so good at it. And there was a graceful degradation of sorts, that if you ask something about yesterday, the network was not trained. The intelligence that we were working with was not trained and was not working. We have seen this before. So if you look at accents and natural language processing, when, for example, Android introduced spoken language on the phones, Indian accent, my accent, or options of that type were very limited. Today, that accuracy has changed so dramatically that I can talk to the phone and literally get everything done by just talking to the phone. And that's the change in language processing that has occurred, which incidentally uses neural networks to achieve that capability. So that change has also occurred. Just like this refinement is happening on the centralized models, so to speak, or cloud-centric models, where I speak to my phone, everything goes to a cloud. Processing happens and responses come back to me, and I don't even realize it, kind of feel that comes. It has its own limitations. So many people, for example, turn off their assistants when they are looking at something sensitive, so that accidentally something doesn't get used or said. And we have seen some of these funny events, right? That it has been a common anecdote between me and my wife, that we're chatting about something, and before you know, our social apps start to show advertisements associated with it. And we get surprised that how did this happen? Now, there is some magic. There are negatives associated with this sort of example that we give. But on the positive side of it, I'm amazed that how is it that our technology has evolved to the point where something like this is happening. There are both sides of the story. Technology is just that. It's a tool. How to use it? Do you cut something and eat it, or do you cut something to kill it? Is a use of that tool. Let's keep that as a backdrop in the process. So people are starting to realize this. Teams are starting to realize this. Enterprises are starting to realize this, that using general AI when I was looking for general intelligence is fantastic. But then when it comes to my organization's policies, my organization's capabilities, there is a competitive spirit, and we would like to keep it the way it is. So in that process, the walls need to be built. The isolation needs to be there. We believe what I know is not what my neighbor knows or what my competitor knows. In the process, we will create smaller models, specialized models, because general knowledge is available from that thing called ChatGPT. But what I know about my policies, my processes, my data, my pricing points, my product refinements that I do, they need to be contained within how I do it. If I'm the world's best coder, and that's my belief system, I would like the code to be generated my way, not ChatGPT way, because then I have a value sense that I attach to it. I may use ChatGPT as a productivity enhancer for what I do, but it's my programming code that's my art, as a way of describing it. And you start to see these trends coming in where the hardware and software evolutions will have to support this. So the notion of nano models, as we call them, where smaller models can be created. Now, if you follow the theory of transformers and large language models, it is massive computing powers required. Is that the same thing? If I was to evolve, the process has to change to adopt how do I create my smaller models. The process has to change to say, if I successfully evolve my nano models, which we have now, how do they interoperate with large language models? How do I create the delineation that when I'm speaking in English, a general purpose large language model is fantastic. But when I'm speaking in my corporate's language is something that is coupled with the general English, and we communicate with one another. I think this is where the evolution of hardware, software, not just the pure play technology like GPUs or how many processors or will I go to quantum at some point in time, but also the software engineering methods as they are applied in AI engineering, as model management evolves. We will see these trends and changes coming in with better governance.
That's a very interesting point you made on nano models, right? And this is fundamentally the question that a lot of businesses are trying to figure out. You go to a healthcare company, they're trying to figure out how do I leverage the 20, 30 years of data that I have in my company on everything, right from the supply chain side to the clinicians to the patients and so on. And how can I bring it together into a nano model, in your word, which is specific to their organization? Where do we think we are in that journey? Do you think the existing 2 or 3 big players have what is needed to win? Or do you think nano models will emerge from a different set of players? What are your sort of thoughts on this?
I think we have to see it under the backdrop of how much acceleration we are seeing. What took cloud computing 10 to 12 years to become mainstay? If you go back and ask the question, when did University of Berkeley publish their cloud manifesto? Beautiful article, beautiful paper. Somewhere around 2008, maybe off by a bit. When did cloud become absolutely standard and everybody was like, without a cloud strategy, we don't live, kind of a view that emerged? Probably is more like 2018, 2020. So about 10 years is how long it took. When was ChatGPT released? November 22. And when did we start talking about nano models? In my organization, possibly somewhere around January, February of 23. So 3-4 months. Speed at which that has changed is amazing. And this is new to many of the technologies too, that they are also learning in this process that what used to happen over a lead time, and in that sense, somebody like me sitting at the very cutting edge of things had a few weeks, few months, few years to work my way through, overcome the objections, mature things, is now happening in a speed of weeks or days at times. So how will this come? Will I have a surprise? I think we'll have to keep a keen eye and collaborate really fast and have a good ecosystem that trust each other. We are tracking hyperscalers. That's for sure where we are going to see, and literally everybody is now in the fray. It's no longer just one company. They are all making more and more parlays. They are all making more and more interactions with, say, somebody like us, who is a systems integrator, and our brother in the same industry. They're working directly with clients to understand where the problem statements are. both the true problem statements that need to be solved, as well as perceived problem statements around security, my data, privacy. And these notions have evolved, right? And they continue to evolve. In 2008, when somebody was saying cloud computing, I've heard reactions like, why would I put something in a cloud center? If their machine is impounded, my machine will also be impounded because it's the same machine. No longer. I don't think anybody says something like that. When we were growing up, we were told, don't put these such pictures on social media. Today, if you don't have such pictures on social media, you're not part of the social media, is how things go. Now, this policy, the perceived problems as they come, they will evolve and we'll find the right kind of solutions. As an emerging technology leader, I believe that we will make some progress on technology front and the others will follow along. So the policymakers, the lawmakers, the frameworks, the methodologies, the scale makers, they'll all adapt to this process and they will sort of follow and make sure that this works in the right manner. So at this point in time, nano models are visible from a set of sources. We being one, there are a few startups which are starting to talk about the similar language. I absolutely won't be surprised if one of the hyperscalers does this and announces it in one of the events or a blog that gets published quietly and something slips out. And that's the fast pace of evolution that we should embrace. So as long as we embrace for that fast paced change, anticipate and trust each other in the ecosystem that we are forming. I'm not saying this is the ecosystem, I'm saying form your own. And then you trust that ecosystem and work hand in glove, we will overcome this issue of it's going too fast.
Absolutely, yes. Things are definitely going very fast. And that brings us to the next topic, right? And we are both organizations that focus on the B2B side of the business. There are definitely some use cases that at Markets and Markets we are seeing evolving. Our healthcare customers are definitely starting to look into how they can use it to accelerate some of the processes. Chemical companies are using it to figure out how they can come up with new molecules at a faster time to market than they've traditionally been used to. Technology companies, of course, they are at the fulcrum of all of this and they're trying to figure out where to fit in the pieces of the puzzle. However, if I still take a step back and think about where the money is, where the big money is in the B2B context, we are still seeing it as a low rise right now. I wouldn't see it as mainstream, but who knows? Infosys has been working with most of the Fortune 500 clients. What's your take on the B2B adoption of AI and how do you see this taking off over the next few months and years?
The raw answer in this particular question, taking quite literally, where is the money? In real terms, there isn't any money. Valuations, if you accept that as real money, then plenty. You can see what's happening in the valuations world in that sense. There's plenty action in terms of test this, explore this, validate this for my business. There's plenty of proof that's saying that this is valid and not just hype, which tells me that if you were to start tracing from our past experiences, again, how relevant are these past experiences when they were lead times of 8 years, 10 years to few weeks? We'll have to test it out because the materialistic impact will also happen in that manner. But without getting into specific dollar sizes, I'm not a financial analyst by any stretch of imagination. In fact, that's one of the weaknesses. I have no shame in accepting that I don't understand dollars as much. But what I do understand is a certain acceleration that happens, certain ratios that you can follow. So as an innovator, if I had 50 ideas, I can easily tell you that of those 50, 5 will go in production and they will churn in multi-million dollars in terms of, depending on the outlook. If I am a systems integrator, my revenue. If I am a corporate world or a financial services company, it's a burn for them, but that has its corresponding amplification in terms of the ROI So if I'm burning $1 million, Infosys makes $1 million in revenues, but the corporation that did it, they burnt with an ROI expectation of 2x or 3x as we see things. Now, these are examples of the past. These are not examples of today or what might happen. So it's a little bit of rear view mirror way of analyzing this. What do I see in generative AI? What do I see in applications of nano models and capabilities like that? I do see 50 ideas. And in fact, I see much more, which tells me that 5 of these will go in production in a very short order. The time for me to generate these 50 plus ideas is so short in relative terms. That time for me to go into 5 production is also going to be that short. So, Vinod, I'm not giving you, I know you wanted probably me to touch on a few dollars. I'm purposefully avoiding the dollar question. But there is massive action at this point in time. Amount of work we ourselves are doing in this space, and by no means we are alone. We are part of an ecosystem. Is amazing, is the way I would put it. And that tells me that the corresponding dollar values that we will see in terms of market making, and if you read any financial analyst reports, you will see the validation of that there is a generative AI economy that is poised to be extremely strong as a way. And therefore, no technology should sort of wait and watch and take this as let it mature. I won't be the first mover. I won't be the second mover. I think we are going to see this, that the acceleration is really fast. It's going to take off. And some of the conventional wisdom, which in itself will be questioned, but the conventional wisdom of we climb a hype curve and we fall in some kind of a trough, then we start productizing, productionizing. In this case, is likely to be relatively flat. We'll simply move from one to the other before we even know it. But I'll circle it back and say that today, do I see big money and is my business leader happy with the generative AI dollars? I think he says, Prasad, they're your size, they're not my size.
Yeah, I mean, we've ourselves as a company which focuses on helping organizations grow. We've been tracking generative AI quite closely, I would say. And right now, we do see a tremendous growth coming in, almost 35 to 40% year-on-year growth in real dollars being spent into generative AI use cases. And right now, we believe the market in the B2B space is somewhere around the 11 to 12 billion mark and going up to 50 to 60 billion in the next 4 to 5 years. So we do see a very detailed view emerging, and for the viewers of this, the report is available online. You can go through it and get a view on what technologies are emerging and how they're impacting multiple industries.
See,
Agree.
this is where our natural intelligence will help us. Thanks for sharing those stats. And now I know the numbers and I can refer it to you and say, Vinod, on one of my conversations, shared this piece with me. And now I have numbers. I have updated my natural intelligence to that.
Absolutely. The power of AI again. Yeah, I have this this theory around divergence and convergence of markets. So the idea is everything first goes through a divergence where people are just experimenting with something new, but the top solid revenue generating use cases will probably be a dozen or a couple of dozen eventually. That convergence is yet to happen. We are definitely seeing things in healthcare, chemicals, and technology space which seem to be cementing that space. But yeah, there are more emerging. I think legal is another area where we are seeing some interesting use cases on critical thinking emerge, where the AI can assist the attorneys, the lawyers before they go into court, helping them justify their arguments better. So there's a lot of interesting work happening in those spaces as well. So yeah, it's an interesting space, Prasad, and thanks for being honest and sharing that it's too early to tell and the potential is definitely there. This also brings me to another topic which has been, I would say, a constant, and it's been explored very well by Hollywood, which is artificial general intelligence, or multimodal AI, as some people have started calling it nowadays. So all the AI use cases that we've seen so far are, I would say, specific AI cases, where you're either helping with image generation, video, text, and parsing of text and so on. But is there truly something that you're seeing emerging with all of these generative models? The chance of something which is more general AI, which can self-learn once it's given some seed context. Do you see that happening with the current technologies, or do you still think that's best left to Hollywood to manage?
I think Hollywood takes the cinematic liberties, as we would refer to them, and amplifies whatever they are doing, the goodness of it and the cuteness of it, as well as the scary monsterness of that technology. But I'll take something that is that we are already experiencing. So my natural language processors, for example, do learn from the way I speak. I talked about the phone assistants that I use and how quickly they are able to do it. We all use a certain way of short forms and languages when we communicate in our text messages or editors and so on. And what is potentially a spelling error becomes a suggested word because Prasad or Vinod are using that particular keyboard, and it's hyper personalized. If I use your phone, I'll be surprised about that spelling. If you use my phone, I'll be surprised about that spelling. But for you and me, THRU through is perfectly fine when I type it, and my keyboard suggests that as the next keyword, next word suggestion with that spelling as a way, and it has learned in the process. So the parts of, is it becoming that fast learning? Is it becoming that self-learning? I think you can see that happening even at this trivial levels of example. I have even more complicated pieces that I can cite where chatbots are learning how business policies or procedures or expense management is being done. Not necessarily in the generative AI style that is still being worked in, but even the erstwhile chatbots as they were learning intents, figuring out policies and so on, and doing the text processing, text understanding as we would have called it earlier. Predictive models is what that is. We were doing the self-learning aspect of it, and it was unsupervised in that sense. A lot of evolution of generative AI is also unsupervised learning. And that's the reason why these models have reached the degree of maturity that they have. And therefore, even in things like I'm learning text or I'm learning pictures or I'm learning Picasso's style of pictures, it is automatically happening in that sense that they are unsupervised learning models in that process. Multimodal is also there, very much around the corner. I'll give you an example where there are technologies, and we have certainly built products and IP deployed in digital customer service capabilities, where if a person is saying something and if you read the text of it by doing text speech to text, it's actually a compliment in that text form. But if you listen to it, it is coming up in the form of a sarcastic remark. Now, that's the sentiment of it that is coming because you heard the voice, not the text that the speech to text converted. In a monomodal interaction, I would read the text and I would draw a completely wrong conclusion in that. In a multimodal where I'm listening to the audio and reading the text, chances are I'll catch a sentiment called sarcasm. It'll have to be taught. The neural network doesn't learn by itself, so I'll have to teach the neural network how to detect such samples and provide enough training data to make sure acceptable levels of accuracy emerge, and then it'll go further. There are other use cases. Many times students learn by being in the classroom where teacher is drawing something on the board or projecting something on a slide, walking around the classroom. Other students are saying something, and the student under purview is also taking notes. They have a recollection to do afterwards. Their natural intelligence collected a certain and retained a certain amount of memory from that point. But they want to revisit that. I'm sure you've heard of this technology where you have a pen and a special paper and you start writing. You double tap the pen, it starts recording, or it brings you audio context to it, and so on. Not AI per se, it's mechanically timed IoT-like system that is working. But if you take analogy further and say that now I want to do multimodal listening and I want to ask questions. Now, ChatGPT teaches us how to ask questions, prompt engineering. I want to use the general intelligence of sorts, but a very limited scope that I'm learning physics, I'm learning organic chemistry, and I want to pick these nuances because it's a hard subject for me. Multimodalness is already there in that sense. I took a general example, but when we do our system learning, system appreciation kind of efforts, we use these techniques today, where we have been able to successfully demonstrate ability to use voice, video, text as an interpretation and allow the students or the new engineers who are trying to create the system appreciation, a different view emerging in front of them. Now, couple that with the prowess of generative AI and in general AI to create system appreciation, talk about problem tickets, logs, code understanding, combine that with subsequent translation methods that we can generate. The whole software engineering piece is poised to benefit tremendously with these tools where humans will do better job of diagnosing problems, anticipating them ahead of time, fixing them ahead of time, that way they don't become problems. Today things have to fail, ticket has to be raised, only then the human goes and solves that ticket. Now if I can automate this process, I'll have better tools, better ways to do things. Some people will call it as, oh, your industry is under threat, or software engineers are going to face an extinction because of generative AI. Not quite. I mean, it is a technology that is only in the hands of humans and controlled by humans in that sense. Sure, there will be disruptions. Sure, these disruptions may feel a little different compared to some of the disruptions in the past, but eventually they're making us better to deliver better quality products.
Absolutely. I think that also goes into another topic around biases, right? Where, yes, these are tools that work for us, but if the tools are configured wrong, then they introduce biases as well. But I really like the whole approach of saying that, yes, there is a morality problem here, there is an ethics challenge here, but these are all tools which are within our control. So it's ultimately up to us. And I frequently keep looking at clients, and because Elon Musk is such a public figure, his whole statement that there is a non-zero chance of AI wiping out humanity comes up very often. I really like the way you put it, saying that, yes, this is a tool and it is up to us. And it is a responsibility of all the engineers and all the people who are working with these systems to make sure that they're run in an unbiased manner and they are working for the improvement of humanity as a whole. So it's a great note to have a parting comment on this, Prasad. And do you have any other things that you would like to add for our viewers before we conclude this conversation?
So the whole notion of bias, ethics, responsibility is a topic of conversation in itself, and I would love to have a conversation with you, Vinod, when we get our opportunities. But I would simply look at it as, I don't know what it is, but Oppenheimer was released at the peak of generative AI hype. And is this coincidence? Is there a bigger master watching us and making us do things in that manner? To use the musky analogy, are we players in somebody else's game in that sense, as he puts it? I don't want to take my own views because then that would be bias. I would simply add to the fact that bias, ethics, and when we were conversing earlier, you'll remember I had shared my personal story of my daughter and how humans learn or how babies learn. They don't have concept. We were born in our birthday suit. They don't have concept of ethics. It's a learned concept. And then I shared with you some of the patterns that children grow with, and what's a cow in one world is not a cow in another world. And that was the example that we were discussing. Again, we can spend enormous amount of time on all of these, but as opportunities become more visible, they become more viable, they become more production oriented and money oriented, elements of ethics, law, frameworks, abidance increase in their value sense. And more we will see that in the generative AI side, where the need for governance will be felt, where the need for ethics will be felt, where eventually lawmakers will harness their own prowess, rightfully so, to make sure that the laws prevail and that there is a certain societal binding that needs to happen. I'm a technologist. I believe in creating new tools, making sure that I can show what the potential is. And I would lean on my friends who understand ethical ways, psychologists, the law mindsets, to help us write a better society for us.
Thank you again, Prasad. I know I would love to continue this conversation, maybe for another hour, but Yes, it is time now to complete this part of the conversation at least. Thanks again for such an interesting conversation. For everybody listening in, again, this is Vinod signing off the conversation with Prasad, Senior Vice President of the Emerging Technology Solutions at Infosys. Please stay tuned for more such interesting episodes on Disruption Dialogues. See you soon again. Thank you.
Thanks for tuning in. If you want to know how you can navigate and thrive in this disruptive era, subscribe to Disruption Dialogues on your go-to podcast channels and stay tuned for more interesting episodes.